Randomized experiments, because the explanatory variable is randomly assigned, we can, for the most part, eliminate confounding variables. So when we have a randomized experiment, we can actually break the influence of confounding variables so that we can actually go ahead and say causation. So randomized experiments are a very powerful way to be able to try to get causation proven, that one thing causes the other. So let's go back to that brain and exercise study. So read through this again. So this is what the article says. Is this a valid conclusion? And the answer is no. It's only an observational study. We're only observing elderly people who exercised and those that did not. We were not actively trying to influence the results with an explanatory variable, and we were not randomly assigning people to one group to receive exercise and one to not. So how do you actually design an experiment that would allow us to have some causation occurring? Well, we could take a sample of mice, randomly divide them into two groups, one where they were given an exercise wheel and one where they're encouraged to be sedentary. So, read through this. Do you think there's evidence that exercise causes brain activity to increase here? Yes, because it was a randomized experiment. Therefore, we can say one causes the other. We can have causation. So how do we randomize? Well, we could go ahead and put all the names in a hat and draw names out randomly. You could use a deck of cards with the names and the cards. We often use technology instead, but it does not have to be done with technology. So read through this. Is there evidence that surgery decreases pain? No, because there was really no control group. As in, do we have a group of people that were in a similar situation that did not have the surgery to be able to say, oh, amount of pain the control group had compared to the amount of pain the people that had surgery had? So a control group is ones that we're trying to compare to. Very similar group to those that are receiving the treatment, so that we can say, oh, the people receiving the treatment, there's a cause and effect, because the people that did not receive the treatment but had very similar situations had this result, where the people who received the treatment had this result. So, a randomized experiment need a control group, at least two different essentially treatments, one that received the treatment and one that did not. You could have more than two groups. You could have different levels of treatment with compared to your control group. So here's another situation. Now, the placebo effect, which was just in this last situation here, really is where people think they're getting better because they're getting treatment for it. A lot of times the placebo effect, or not a lot of times, but the placebo effect is, for the most part, somebody thinking they're getting better because they're getting treatment when they're not actually getting treatment. It's all kind of in their head. So one study suggested that 75% of the effectiveness of antidepressant medication is because of the placebo effect. as in people think the medication is making them get better when they might have just been taking a sugar pill. And it's just all within their head that they are actually getting better. And they might actually be getting better, but it's still just all in their head. So control groups are often given the placebo or fake treatment that resembles the active treatment that's given to your group. The placebo people don't know that they're getting the placebo, and they don't know if they're getting the active treatment. Neither group knows what they're getting. They know that they're getting something, but they don't know if it's the actual treatment or a placebo. Ideally, if you're doing a randomized experiment, you want to do a double-blind experiment in which the people involved don't know if they're getting the treatment or not, and those doing the research don't know if they're getting the treatment or not. Because sometimes the doctor giving the treatment can kind of influence the results of that person. And so you want to do double-blind studies whenever possible. So consider this situation. So the difference 1 to 9 was really quite big. Can we conclude that green tea really helps prevent prostate cancer? Yes, because it was a good randomized experiment. So therefore we can say there's causality. One causes the other. So one of the types of randomized experiments is a randomized comparative experiment, in which randomizing the cases in which the different treatment groups are given. So we have matched pairs experiments also. So a matched pair, besides randomized comparative experiments, are both valid ways to do these types of experiments. But a matched pair could be like you're testing sunscreen. So on one arm you put brand A, on the other arm you put brand B, and you go outside for 4 to 5 hours, and then you come back in, and the researcher observes the effectiveness of your sunscreen. It could be a match pair, could be like a before and after situation where you're looking at number of cavities that people got with brand A toothpaste and brand B toothpaste. But the order in which they're assigned is randomized. So back to the sunscreen situation, which arm gets which sunscreen is randomly assigned. So here we have a situation, read through it. So this was an example of a matched pair. They were randomly assigned whether they did the study or the electronic one first, and then they were comparing the results. So why not always randomize? Well, it's ideal to have that, but not always possible. Sometimes you can only get observational studies because it's not ethical to actually do the experiment. So you want to ask yourself, was the sample randomly selected? If yes, then you can make generalizations to the overall population. If no, then you cannot make generalizations. Was the explanatory variable randomly assigned? If yes, you can make conclusions about causality. One causes the other. If not, you cannot make causality conclusions. So we have a population, we collect our sample, we make conclusions about that data. But you need to ask yourself, was the sample randomly selected? Was the treatment randomly done? Was it an experiment? So you really want to have a randomized experiment, but it's not always achievable or doable. So you want to go ahead and say collect data, and it's not a randomized experiment, but you did a random sample, and that could be like election polling, and that's just a study. Now, to get causation to occur, you need to actually have a randomized experiment or a matched pair randomized experiment in which you can establish causality where one causes the other. So just because two things are associated does not mean one causes the other. Observational studies often have confounding variables, and you cannot make any conclusions about causality that one causes the other. Randomized experiments involve randomly determine the level of the explanatory variable, and they can then be preventing confounding variables from influencing the results, so then you can have causality um, in a randomized experiment. You also need a control group in which to uh, compare your results to. And you got to be concerned about the placebo effect. And if possible, use a double-blind situation.